And like 99% of things are not useful. So you should just focus on try to figure out what that 1% is, right? And then once you figured it out, then spend all your time, right, trying to optimize on that 1%.
Hello, everyone. Welcome to the Data Scientist Show. Today we have Youyang Gu. Youyang is the creator of COVID-19 projections.com. In 2020, while most COVID projection model failed, without any experience in medicine, he created a forecasting model that outperformed almost all medical experts. Yann LeCun, Facebook's chief AI scientist, stated that Gu's model is the most accurate to predict deaths from COVID-19. The model was cited by the CDC in its estimates for US recovery. Currently, he is a member of the technical advisory group at the World Health Organization, working on laying the groundwork for a comprehensive global study to document and analyze differences in levels of mortality attributable to COVID-19 between and within countries. Welcome to the show, Youyang.
Yeah, thanks for having me, Diana. It's a pleasure to be here. I'm excited for our conversation today. I know you're there's a lot you're looking to learn from me, but I think I can. There's a lot I can learn from you as well.
Yeah, thank you. I'm very excited. And today we'll talk about his career journey, how he built a model, lessons he learned, and what are some exciting projects he's working on today. And if you've been enjoying the show, subscribe to the channel, and I appreciate if you give me a 5-star review. So let's start with your career journey. How did you get into data science?
So I I studied computer science in college at MIT, and but I was actually during my undergrad I was more of a systems type of guy. One of my summer projects or one of my research projects was on like compilers. I was working on a compilers lab, and we were looking at like system design and things of that sort. So it actually wasn't until kind of my master's, also at MIT, that I started learning more about machine learning and data science and kind of that sort of topic. And so my master's thesis was about using deep neural networks to look at food adulterations, basically like contaminations in food, and seeing if there's a way to we can detect, right, where certain combinations of food or ingredients are more likely to be adulterated. So, for example, like honey is one of the most commonly adulterated ingredients out there because real honey is very expensive, but you could easily replace it with, say, fruit corn syrup, right? And so, so that was kind of my first dive into kind of the area of machine learning. And afterwards, and I went into finance, more specifically high frequency trading. So that was basically kind of all hot, very advanced technical quantitative methods for, right, predicting the future, right, or trying to. So that was kind of the bulk of when I learned a lot of my modeling experience, and so that
Yeah.
yeah.
And what made you want to build a COVID projection model?
Yeah, so I think it was just everything kind of ended up lining up at the right time. I think I was when COVID started, I had kind of stepped back from my job at finance. I was kind of doing more sports analytics on my own, and with a buddy of mine. And so when COVID hit, all I remember I was walking to my car after I had a kind of work session with my buddy, and I got a text saying, "Oh, the NBA season has been suspended due to one of the players testing positive for COVID." So that was when I realized that kind of things were real, and it wasn't just kind of something you hear about in the news. and so and so kind of the whole sports world kind of shut down, and so I had kind of no no extra work in that area, so I had free time that freed up. So I decided, oh, why not build a model for COVID to see kind of right when things will potentially kind of end. That was optimistic of me at the time, but here we are 2 years later. I'm not still quite sure that COVID has ended, but that was kind of just how I got started. Was I had some free time in my hands because of right all of the cancellations, and so I decided I'll put together a model, see what happens.
Yeah. And when you started to look at the data, what type of challenges you realized?
Well, the first challenge was right is just there's very little data.
Mm,
And so, right, the types of projects I've worked on in the past, the types of modeling I've done in the past, is always with a lot of data. And so in this case, right, COVID, it was only kind of been going on for a month or two. So, right, there's only so much data, and the existing data that were out there are very incomplete and very inconsistent, right? Because, for example, at the time, right, this was back in March 2020, we had cases, maybe number of tests, and then deaths, right? Those are like kind of the three only data sources that we had,
yeah.
and testing is very wishy-washy, right? We don't know where it's impossible to get a test in the early days, so that data is not reliable.
Hmm.
Cases aren't reliable because it depends on how many tests you do, right? The more tests you do, then
Yeah.
of course the more cases you have. But if you don't do tests, then you don't have cases. So that's not reliable.
Yeah.
So the only thing that's semi-reliable are deaths, right? Because usually, at least in like first world countries, right, people who will get sick enough will go to hospital, and then those who are suspected of COVID will get prioritized for testing. So usually kind of in the early days deaths, even though they're still not the best, kind of still very noisy data, but it's kind of the best we had. And so I thought, I'm just going to the model that I'm going to build will only accept deaths as an input to predict future deaths. So that's kind of the first major decision that I had to
Hmm.
make, and it ended up uh, that ended up being a very good decision in retrospect, right? Because we had many other people attempt to basically do modeling with all these other data sources, and you end up actually just fitting on the noise rather than on the signal,
Mm.
basically overfitting. And of course, I'm sure if the people who are watching are very well aware of that phenomenon. But this is one of those cases where it did matter very much.
Yeah. Yeah. Thanks for sharing that. So based on the news and the documentation I read about your project, I think this is actually a very important decision. Correct me if I'm wrong. I think a lot of other health experts were actually using the cases or testing data, and you said those are wishy-washy, and you provide your analysis, your assumptions around it. So my question is, how did you test your assumption around the testing data and those cases data? How did you run some experiments so you can know that those data are not good enough for you to use?
I probably didn't run any experiments per se. It was, I guess, one was just was doing reading about, right, like the amount of data and what the types of data sources that were out there. And actually, I remember distinctly one article I read that kind of stuck out to me was one by on 538. I believe it
Mm,
was Nate Silver that wrote it, and so
yeah.
I looked up a lot to Nate Silver because of like the work he's done for election forecasting and
Hmm.
sports forecasting. So he basically wrote that, oh yeah, like these numbers are very unreliable. And
Mm,
of course, I've also read his book, The Signal and Noise, right, where he talks about, right, like picking data and overfitting on various things. So using that kind of as keeping that in mind, I made that decision. And also it was just easier, right? To be honest, right? If you're only working with one feature, one
Yeah.
column, it's a lot easier than if you had two or three or more. So even just like kind of like on the selfish side of things, right? It was just easier to
Hmm.
use a single data source.
Yeah, that makes sense. And was it your baseline model?
What do you mean by baseline?
So, okay, what I meant was when you first used the death for your projection in the beginning, were you using it as a baseline model? Was it the first iteration of your project?
Oh yeah. So I guess the timeline wise, yeah, I think I spent probably like 2 days putting together the model. I
Hmm.
guess before then I read a little bit about SCIR, and so that's like a classic infectious disease modeling. So it stands for susceptible, exposed, infectious, recovered. Right. So you basically
Hmm.
model individuals or populations based on what state kind of they're in. And I so decided to take that approach. But I think the traditional academic kind of versions use differential equations
Hmm.
to do a lot of these calculations and gradients, right? Like
Yeah.
you have to take the derivatives of the different, right? Like the amount of susceptible into the number of infections and things like that. So, but I
Hmm.
have not taken differential equations since right since like freshman year of college. I don't remember anything. So I decided to do kind of a more state machine approach, right? So
Hmm.
that's kind of just more like classic, kind of computer science approach where you kind of model individuals based on what state they're in, and then you have like kind of like this transitional probabilities where, right, if an
Hmm.
individual is susceptible, each day they have kind of an X% chance of being exposed, right, and you have kind of those probabilities. And then if you're exposed, you have also these transitional probabilities to become infected. And
Hmm.
if person infected, you can either recover or pass away. So kind of there's also the probabilities in there. So that kind of process I put together in like a day or two, and then actually one of the hard part I would say is actually
Hmm.
putting it right. Like I thought, okay, well I have a model. Why not just like like show people this model? So
Yeah.
I wanted to kind of like put it on a website so I could show people. And that's something I've never done before. So that took me a while to kind of learn how do I put a model on a web page.
Uh-huh.
And but eventually I think I used GitHub Pages, and they were
Hmm.
it's a very easy tool to use. And so I got the whole site up and running. Uh, and the whole thing took about around a week
Yeah.
to get up. So
Yeah, it seems like the initial version of the model was created pretty fast. You said 2 days, and then you took some time to put it up. Of course, after you you looking into the data and did some reading and decided what feature you wanted to use. And so, at that time, did you read about other medical experts' model, or did you try not to be biased by other people's model?
yeah, so there were a couple models at the time. I think the ones that were the most prominent that kind of led me to also build the model in the first place is there's two of them. One came out of I think Imperial College in London,
Mm.
where they were predicting, like if no action is taken, there's going to be 2 million deaths in the U.S. by summer 2020. Right,
Yeah.
so that's obviously very scary to hear, right? Especially if like you are not have that technical background to like understand why that they're saying what they are. And so that caused a lot of panic, right? Because the news articles picked that up, and that got disseminated pretty quickly, and that also probably, I guess, led people to shut down very quickly as well.
Mhm.
And then, but on the flip side, you had a group, IHME, coming out of University of Washington, and they were saying, oh, like there's going to be 60,000 deaths in the U.S. by August 2020. So that was the model that actually got picked up by the White House, and infamously, I don't know. And so every day, right, on the news, it was like the press conferences, you just hear, oh yeah, like the modeling we had, we're saying, oh, 60,000, 70,000 deaths. And at the time, right, every day, you're just seeing the numbers, right? Like we're at 50,000 every day.
Yeah.
2,000 more, right? 3,000 deaths more. And I'm just sitting really looking at this like this is so wrong, and I don't know why, right? Like no one is questioning, right, the model. They just kind of believe it because right, it's like a bunch of, right? I mean, like the group that built the model, right? They do have a good reputation in kind of their work in public health. So yeah, I guess, right, there's no why question them. And so that was frustrating because, right, like I don't, yeah, I agree. They've done a lot, right, with the Bill and Melinda Gates Foundation in terms of kind of, right, like advancing public health around the world. But that doesn't mean that their model for COVID is good, right? So those are kind of the two models at the time that got a lot of attention, and I thought, that it just doesn't look right, especially with kind of the numbers that I was getting. So that kind of motivated me to kind of keep trying to push my model kind of more in the public eye, right? Because I thought, people deserve to see kind of another version, right? Like maybe probably a more accurate version of what's going to happen.
Yeah. Thanks for sharing that. I want to ask more about the responses you get, but I have some technical questions. So previously you mentioned that you try to um, come out with a probability based on to predict what is likelihood of someone will get COVID and also death. Can you share how did you construct the probability?
Yeah, sure. So the basis of right, these probabilities. Well, so I talked a little bit about, right, the underlying kind of mathematical model, which is kind of like this SEIR component, right, where every individual belongs in kind of a particular state, and so we had, right, these transitional probabilities, right, where they would move from state to state. And so I modeled each region separately. So for example, right, if it was New York, they had their own SCR model. If it was California, they had their own model. Italy, right, own model, things like that. And so you start off, as I was just take an example with New York City, right? Or just New York in general. So we had, right, like say like 20 million people, and as like the population size, and so, right, we expect say at the time I think there were uh, a few hundred deaths per day. So I used kind of what we know is the IFR, the infection fatality rate. At the time, we thought it was around 1%. And so, if there were, say, right, 500 deaths per day, that means that there were 50,000. Did I do that right? Yeah, 50,000 infections per day,
Yeah.
uh, 3 weeks earlier, right? So kind of working backwards, because, right, it takes about, at the time we thought, around 3-4 weeks for someone to, right, catch COVID and then progress to a point where they eventually, right, would succumb to the disease. So that means that, right, we kind of like 50,000, but of course there's some underreporting. So, right, I think there's some variables that kind of bumps that up a little bit more. So maybe like 100,000 infections per day. And then I include what's called the reproduction number. So, right, this is the RT or R naught kind of, right, it's a class. It's like the most important number in infectious disease modeling. And so if R, right, is this R value is above 1, it means that the the pandemic is increasing, more people are, each person is
Yeah.
infecting more than one person. If it's less than one, it means the pandemic is dying down because by less than one. And so basically every day then we had probability of like how infectious someone is. So you can kind of usually it takes about 5 days, or I think like 5 days for someone to become infectious after contracting COVID. So I just made kind of like a probability density kind of array where like, oh, like say like the peak is at like, they're most infectious on like day 5, right after contracting the disease. So you can kind of end up doing a convolution with the number of individuals who are infected with like the probability that they are infectious. And so if you convolve that and then multiply it by the R value, right, the number of people in expectation an infected person would infect others by, then you can get the next day, right? The new infections for day T+1 or right T+5. So that's roughly kind of how I kind of calculate the newly infected every day. I don't know if that's clear or not, but let me know if I should kind of clarify at that point.
Yeah, I think that's clear. I think you referenced the SCIR model, so that's one that is a commonly used model when people model like infection disease, right? So it's
Right.
kind of something you learned when you start to do this model, and also in your website, I think somewhere I read you call it like a instead of forecasting, call it a nowcasting. Is it because every day you update a model, just do like T+1?
So for this particular model, I think it is forecasting because I'm
Okay.
kind of like predicting where deaths will be in the future. Uh, I had two kind of other versions of the model, right? So basically, this like fall 2020, right? So after the first wave has passed, um, I kind of winded down my death forecasting model in like October 2020, right? Because by then we had a lot more data and more kind of robust data coming out from like all these different institutions and organizations. And so it didn't really make sense to only use deaths to predict future deaths because right now we have a lot more data to work with.
Yeah.
So I winded down death forecasting model, and then I started a new model. That's the nowcasting model, where I am basically nowcasting. So estimating how many people are currently infected and have been infected with COVID. So this was during the winter wave of 2020, where I was saying, okay, like 30% of the population have had COVID at some point, or currently there are one in every 100 people in this state or in this county are infectious with COVID, right? So that just kind of helped people better understand kind of what the situation is in where they live, because I think by that point, by winter of 2020, there's actually like I think around 40 models that were doing death forecasting, right?
Yeah.
Because right, these types of models got a lot of attention, including mine. But I realized that there are very few models that were basically estimating how many people actually have COVID right now and also have had COVID in the past, right? Because past infection that does also confer immunity, at least right at the time. So that was kind of important to know because like, there's a very big difference between if like 40% of the population have been infected versus just say like 10%, right? Then the region with only 10% previously infected is much more susceptible to a next wave. particularly a winter wave, a winter surge, than a place that have already seen 40% of the population affected. So that
Yeah.
was kind of the next iteration that I was working on.
Oh, got it. That's helpful because when I was reading that, I was curious what is the value of nowcasting model. I think even you're not doing forecasting, but have a correct understanding of what's going on right now, you can understand for a specific region what might happen in the future. And also, I think at that time, just counting how many cases correctly, the reporting also sometimes it can take a few days to know what happened in the past week. So if you have a now casting that's accurate is also helpful for people to just have a sense of what is going on today because the actual counting is delayed.
Right.
So regarding this, so you mentioned later on we have more data and also a lot of data get corrected, so you can actually looking at the case number. I think one thing you mentioned in the blog is there was a inflated infection rate because in the beginning the testing cases were not counted by like unique cases, like one person have multiple tests for the same case will be counted as multiple cases. So how did you find out there was this inflation in this metric?
Yeah. So this is kind of what you're referring to. I think is the infections estimate model. So not the
Right.
death
Yeah.
forecasting model, right?
Yeah.
So that model, right? So I use percent positivity as kind of a heuristic for how prevalent the disease is, right? So the
Mm-hmm.
idea is that the higher the test positivity rate, then the more undetected infections there are, right? So
Yeah.
if your test positivity is say 1%, then chances are you're catching a lot of the cases. But if it's say 30%, right, one in every so or 31 in every three, then
Mm-hmm.
that means you're probably not catching a lot of cases, and so there's probably maybe like 5 times the number of true infections compared to the number of confirmed positive cases.
Yeah.
So I try to use that to estimate the true infections in say each state and every county. But as you referred, there are problems with kind of counting tests and test positivity because unfortunately in the US, every single state has their own system of how they calculate positive tests, negative tests, confirmed cases,
Mm-hmm.
etc. And so it's very difficult to directly compare between state and state if you just looked at, say, test positivity. So
Mm-hmm.
an example of that would be so, like, say, some states like South Dakota only reports tests based on number of like unique people. So if
Mm-hmm.
one person goes and gets 10 tests, they would only count as one test. Whereas most other states, right, if you get tested, even if the same person gets tested 10 times, that counts as 10 tests. So
Mm.
then if you end up getting one positive out of the 10 tests, right, your test positivity rate would be 10% in most states. But for South Dakota, because if they only count unique people as one test, then it's one case divided by one unique person. So your test
Mm.
positivity rate becomes 100%, right?
Yeah.
Even though it's the same situation. So therefore, these are kind of nuances where
Mm.
you can't just a state that's 10% versus South Dakota as 100%. It's the same situation, but vastly different numbers. So I had to kind of go into the data and make the appropriate adjustments so
Yeah.
that we can compare these states equally. But that's just something that just kind of more on kind of a data manipulation side, right? We have to pay
Mhm.
attention to what the data actually means rather than just go in kind of like just like import data and then run model and expect to the answers to be meaningful.
Yeah. Yeah, that's a really important point. And also, I forgot, was it from your website or some other blogs? I think one thing you figure out there's an inflation is through compare different states. Another thing is, I think just within one state, as time passed by, the assumption would be more, there would be more COVID cases, I think in 2020 or early 2021. However, it seems like the positive infection rate somehow dropped. So I think some people also have the assumption because of it's not supposed to be dropped as more people catch COVID. So people have the assumption probably some early testing results, the ratio was inflated. Was it the case?
I think so. I'm not quite sure which one you're referring. Are you referring to early in the pandemic or more later?
Yeah. Sorry. Yeah, I meant early in the pandemic.
So I guess so the issue early in the pandemic is that right there were very few testing being done, and
Hmm.
so a lot of states just actually don't didn't have any tests whatsoever.
Yeah.
And so even though if you're saying like, oh, this state is reporting 100 cases, the trend it it tells us nothing about how many people are actually affected.
Hmm.
There are times my model is saying kind of in early March 2020, the multiplier for number of true infections is 20. So that means for every confirmed case, there were
Hmm.
probably 20 true infections. So if a state reported say 1,000 confirmed cases, then there were probably 20,000 infections. Maybe 2 weeks prior to the confirmed case.
Yeah.
So
Yeah, got it. So it looks like at that time still it's very hard to figure out what is the true infection rate. And then, but through comparison um, across different states, it can give us a sense of what is kind of an outlier look like and what is the majority look like, and help you figure out what is the how do you make the adjustment.
mhm. Yeah, I think. Oh, I think I know what you were trying to ask earlier. I think there's. Yeah, I was looking at some states, right? So
Hmm.
basically, you have number of cases, and then you have number of deaths,
Yeah.
and right. Sometimes, for some reason, some states there's probably a lot of politics involved in terms of like reporting what counts as a
Hmm.
COVID death and what's not. And so there's some states I don't know for sure, but they're like if you look at their case numbers and then compare them to the death numbers, right, maybe like their death numbers are very low. And so, one, you can say, oh, maybe like they're just better at treating their patients, right,
Yeah.
or those that are infected. Uh, but the other case, right, is maybe they're right, like they're not quite reporting all
Hmm.
of the deaths in that state, right? So there you could do a lot of various analytics with that, and kind of figure out, okay, like what is what I call it the implied fatality rate for each
Mm,
state,
yeah.
right? Based on kind of right the number of cases and deaths that are out there. And so if a state
Hmm.
has a very low implied fatality rate, then right, of course, maybe they're just doing a really good job, but maybe there could be something right hidden under the surface.
Yeah.
Of course I don't I don't know what the answer is,
Hmm.
but right, so I just wanted to kind of share the results, and maybe someone else can find out right what's happening there. So I think
Hmm.
like back in this was like summer 2020, I noticed a lot of like the Sunbelt states, like for example like Florida, were reporting lower deaths than what I thought they should be.
Hmm.
uh and but it turns out that they were just kind of really maybe just like backed up or delayed in terms of reporting that. And actually after I kind of announced my findings like a couple weeks later, their deaths like started to kind of go go climb up pretty
Hmm.
significantly. And
Yeah.
so
Yeah. So, how long do you remember how long did it take for you to look at the the inflated infection rate and figure out this issue?
So I think at the time I was just kind of doing uh, various research with COVID, running a bunch of numbers because right, my death forecasting model was running every day. I didn't had to make too much changes. Uh,
Yeah.
every week I would look at it and look at its performance and say, okay, like here's where it's underperforming or underestimating deaths. So these regions I'm overestimating deaths and make the appropriate changes right for the next week. But for the most part, I didn't do too much tweaking
Yeah.
for that part. So I had a lot of extra time where I was just doing research into looking at other numbers. So for example, I was looking at uh, school openings and how that's associated with cases or like mask usage, if that is associated with decreased COVID rate prevalence rates and things like that. So one of the things I looked at was this like implied fatality rate metric.
Got it. And you mentioned when you look at the actual death versus the projected death in the death projection model, you make some tweaks. So how do you take the feedback from the actual data and then adjust your model?
It was a tricky experience because there are times where I want like if I'm under forecasting this, then let me just like bump it up, right? Or if I'm overestimating, let me just like bump it down.
Mm-hmm.
And the problem is basically it just becomes overfitting, right? Where like you
Yeah.
see some data and you basically have some like n equals 5, n equals 10 data points that suggest something, and then so you do it, but it turns
Mm-hmm.
out that you end up kind of overfitting for that particular data point rather than kind of modeling the true signal.
Mm-hmm.
So I actually like kind of purposely tried to do this as seldom, right? Like not as frequently as I want, because I know that if I do it frequently, then it's actually going to cause more overfitting.
Yeah.
And
Yeah.
so, but of course, at the same time, right, I had to kind of know when the model is actually wrong, and not just, a blip, right? And so
Mm-hmm.
it was a hard balance, right? Trying to kind of juggle those two, where you don't want to update it too frequently, but at the same time, you don't want to be behind, right? When the dynamics of the pandemic changes and you don't adjust
Mm-hmm.
to that.
Yeah.
So I think that I call it kind of more of an art than a science at that point, because it really like there's really no science based. I'm not using any rules to
Yeah.
do these tweaks. I'm just like, I think this is wrong, or I think the dynamics need to be changed, and I just like do it and see what happens, and then the week after like kind of reassess the situation. So that honestly I just is just mostly trial and error, I would say.
Yeah.
Then I definitely made a lot of errors. So uh but yeah, it was a learning experience for sure.
Yeah. So I guess by the adjustment, most of the time the new model works better than the previous one without adjustment. But I guess there's still some small tweaking, like you mentioned. Sometimes higher, sometimes lower. Do you usually add a delta or you add like a multiplier
To what?
to the model? You said sometimes it's underperforming, overperforming, and then you make some adjustment.
So basically, there are the core of the model is based on kind of this reproduction number, this R curve, right? So I basically
Yeah.
have an estimate of the reproduction number per day, right? So every
Mm.
day in the past, and then every day in the future. And so this R value turns out to be very important because, right, like if an R of 1.1 is very different from an R of 1.2 because
Mm-hmm.
of like the exponential kind of
Yeah.
nature of, right, like if if it's 1.1, then every day you're multiplying by 1.1 versus 1.2. So after a week, right, you get kind of very vast different numbers. And so that was kind of a lot of my tweaking was just actually just based on kind of where I think the reproduction number will be in the future, right? So kind of inputting, I have to give the model kind of a range, right? And then kind of like, and then I let the model figure out what is the optimum value in that range. Which, by the way, I just used grid search to kind of learn all the parameters, which is basically kind of the simplest, right? Hyperparameter optimization technique there is. Right? You learn this in machine learning 101.
Yeah.
But it was very useful because I only had, I think, like 13 parameters or something. So, and most of the parameters are kind of like pretty fixed, right? Like, for example, the fatality rate, right? I kind of figured out it was around 1% early on, and then it kind of dropped to maybe like 0.7%, but it doesn't change, so there's no need to search that parameter once it's fixed. So the things that do need to be searched are things like the R value over time.
Got it. Yeah.
So so these parameters are kind of mostly what I was just tweaking to make sure that the model is kind of just like kind of nudging it to make sure it's like going in the right direction, because if it has the wrong R numbers, then it can the results can kind of go off. So
yeah, thanks for sharing that. And you also mentioned you're monitoring how many people are wearing masks, do school reopen. Do you did you add more features based on that, or you also use that to tweak the the parameter you mentioned?
so those are kind of usually separate. It was just to kind of help me kind of understand COVID as a whole better, rather than just predicting number of deaths in the future.
Yeah.
So things like I think I looked at like school reopenings. I think there's a big debate, especially in the U.S. about like whether or not we want to like open schools. And there's definitely like political side, but I mean I wanted to focus on kind of the science behind it. And for me, I looked at kind of like some of the data that was published out there. Like there's like a paper coming on CDC that's saying, oh, like schools that closed down had they claimed that like schools that did remote had fewer case prevalence in the community than schools that had in-person learning. Right, this is during kind of fall 2020. But then I looked, right, like I look at the data, and when it came to, but the implication is wrong in the sense, oh, they were kind of implying that, oh, if you close schools, there's lower community prevalence, which is the kind of the worst kind of mistake you can make in data science, right? Like correlation is not causation.
Yeah.
And so, but of course, right, like when they released that paper, a lot of news organizations picked it up because they're like, oh, look, right, like here's the CDC said, right, closing schools means less cases. And so that caused more political, it's debates out there. But right, it's not causation by any means. It's just like places with higher COVID prevalence probably it was just at the time, right, it was just simply an association rather than a causation. And so when we actually looked at winter 2020, long and behold, it turns out that right the schools that had remote learning, right, that those communities suddenly had a large surge in cases in the winter, compared to schools that are in regions that were hit hard early in the summer.
Yeah.
Right, it's because of this idea that right, like if you have prior immunity, you're less at risk for a future wave, right, than places that may not have that immunity. And that's kind of very important to understand. And I think that's something that a lot of people is, in the general public, and even I think some experts, right, they don't understand that, like, right, this is a long-term issue that we're tackling, right? COVID is not something, like, right, like if you just shut down everything for 2 weeks and it's gone,
Yeah.
right? It'll be here for many years. So, it doesn't make sense to look at, possible interventions or restrictions that, right, have short-term impact, right? Oh, like if you close down all, restaurants, then yeah, like maybe in the near term, right, there will be fewer cases, but you'll have to reopen the restaurants at some point, right? So, but the moment you reopen them, long and behold, a lot of these people don't have immunity and go in, and the right cases are gonna go back up, and they might even go back up much stronger than if you just kind of let things not close them down in the first place. But so that's kind of that I can go on about that, and that's a completely different topic as well. But yeah.
Yeah, it seems like from the beginning you didn't have any background in healthcare, medicine, but as you learn, you started to develop some intuition around what type of things make sense or not. So I'm curious. Previously, you mentioned uh, the decision about in the beginning only looking at the death data because it's more reliable, and then later the other cases you mentioned, you found some cases, testing cases, the positive rate was inflated. So besides those, what are some other important decisions you made through the process?
Well, one thing that helped me was actually I used Twitter quite a bit uh,
Mm,
during kind of that phase when I was building the model. And I at first started using it as a way to publicize, right, kind of the model that I built, and I wanted people to kind of to look, right, visit my website. And so that ended up kind of taking off once I was able to connect with like a professor at University of Massachusetts Amherst, the Reich Lab, and they eventually kind of got me on to connecting me with like the CDC, and they put my model on the website, which, right, is how a lot of people ended up hearing about my model.
mhm.
And then, but I used Twitter to kind of, right, like interact with different people because, right, this was during the lockdowns where everyone was just at home every day. And of
Yeah.
course, since I had no experience in infectious disease modeling, right, I didn't know who to talk to or, right, to
Mhm.
learn about, how I can improve my model. And so I just used Twitter. I'm like, okay, like, here's my results. And of course, people on Twitter and social media in general love to have an opinion.
Yeah.
So whether whether I liked it or not, they would, give me their honest opinion.
Mhm.
And of course, some people word their word their opinions nicer than the others.
Yeah.
So that was something I had to deal with. But for the most part, I learned a lot from just kind of going on Twitter and reading people's feedbacks, right, and kind of basically having my doing all of my updates, right, on Twitter. So every time I had a new
Mhm.
model update or release, I can kind of, right, just like type up an update on Twitter, tweet it out, or kind of like people have suggestions, can we see, this feature on your site? And
Mhm.
if I see a lot of people request that, but oh yeah, that makes sense, right? And I'll go ahead and improve that and put that feature in. And so I thought, my that decision, right, to basically use social media and Twitter particularly was very kind of influential in how the website turned out. And right, I don't think it would be kind of the version it is without, right, me using the platform. And I think it also became very popular because a lot of um, uh, experts also used the platform
Yeah.
during COVID, right? So I was able to learn from them as well, and a lot of the papers and research, right, that I read and used to help build a model came
Mhm.
from, right, reading a lot of these expert Twitters tweets and kind of going through what kind of they were referencing, right? So all of
Mhm.
that stuff I wouldn't have been able to access had I not, right? Had I just kind of been at home on my kind of on my own. So yeah.
So getting feedback is very important for you to improve the model and then improve the project.
Nowadays I don't use Twitter anymore.
Yeah.
Because just for a variety of reasons. I think there's a lot of positives from Twitter, but there's also kind of a lot of
Mhm.
negatives, right? In terms of like, oh, you
Yeah.
can end up in an echo chamber because of how Twitter and kind of social media is in general, right?
Right.
They want to, their main purpose is to maximize engagement and interaction. So then what
Mhm.
they would do, right? They would just try to, right? If everyone's posting things that you agree with, you're probably not going to interact with it very much, right?
Yeah.
So they purposely try to pit, right, these different groups against each other to,
Mhm.
right, kind of get people hooked onto the platform. Like, oh, I have to, right, debate with this guy, prove him wrong or whatever.
Yeah.
And I don't think it's the most healthy
Mhm.
kind of way to spend one's life. So I've
Yeah.
since kind of stepped back a bit from Twitter, and I only use it if I want to kind of make any announcements and things like that.
Yeah. Thanks for sharing that. And then in the early phase, when you just publish the model, because your model is different from a lot of other models, and then you receive a lot of criticism, and a lot of people, have doubts on your model. Can you tell us a little bit about how that affected you, and how did you handle that?
Yeah. So try to kind of, uh, I try to listen, right? Like there are times, of
Mhm.
course, people would, I guess, right? They say, oh, like obviously the ones that are like, oh, your model sucks, or your model's meaningless, that right? That is not helpful. But there, right? Like a lot of times, people have legitimate criticisms and issues with, right, the stuff that I was building, and as long as, right, that you're nice about it, I try to, like, try to think about these things from that perspective and say, oh, okay, maybe like this guy has a point, this person has a point. Let me see if there's anything I can do to improve on that.
Mhm.
And so I think, I guess there's one example where I had like a professor of epidemiology, kind of initially, right, like someone like asked him for his thoughts about my model, and he said something like, oh, kind of he's wrong, like it doesn't this model is like, it's meaningless, right? It doesn't,
Mhm.
we shouldn't, you know, uh, something along those lines. And then I kind of, I guess, took it a little personally, and I kind of wanted to prove him wrong.
Yeah.
And then we ended up kind of talking, DMing each other and talking it out. And he was, oh, yeah, like, sorry. I said that I mistyped what I meant. I meant that, we shouldn't rely on just rely blindly on a model to make
Mhm.
decisions in general. And then I thought about, oh, yeah, I'm like, yeah, you're right. Like, yeah, my model has been, somewhat accurate in the past, but that doesn't mean that, it's going to be accurate in the future. And you shouldn't just, right, trust the model because it's been accurate in the past or whatever. We should always still do our own kind of thinking, because at the end of the day, a model is only a model. It's only as good as the assumptions, that you put in. If the assumptions don't hold anymore, then the model is essentially meaningless. So, right, so we ended up kind of agreeing with each other, and realizing that, like, we're both kind of on the same page here. Is just, right, the way Twitter is
Yeah.
brought up, right? It just kind of makes try to always pit people against each other, and that was something that I didn't realize in the
Mhm.
beginning. But once I realized that, it kind of, right, like I understood it a bit more.
Yeah. Thanks for sharing that story. And also, it's very hard to sometimes have a very thoughtful conversation just with 140 to 80 words. And also, like you mentioned, I think social media sometimes promotes the opinion when it's kind of more extreme. and people want to be right, and they forget about the purpose of communication, which is to find out the truth. So when you and your model first got the attention on Twitter and from the media, what was it like?
It was interesting because I think right I wanted to use Twitter to kind of let people know about the model,
Mm-hmm.
and but I wasn't really kind of expecting too much since I had no experience with infectious disease modeling. I thought, like there are a lot of, I'm sure there are other models out there, and I'm just one of many. But then I ended up I actually also like emailed and DM'd, messaged a lot of reporters and journalists,
Mm.
and of course, I don't think any of them reply to me. I mean, I don't blame them. I'm just some random data scientist with a website.
Yeah.
But it was interesting because I ended up working with Professor at UMass, and then eventually he was able to help me kind of. His group was working with the CDC to kind of collect and aggregate all these COVID models, and so he ended up adding my model to with the CDC's approval, right, to the
Mm-hmm.
website, to their website. And I think I was like the first non-academic model to be
Yeah.
added. And so I really appreciate, right, kind of the Reich Lab and the CDC for making that decision to include my model, because right, I'm sure that was kind of a difficult decision because right, like I who is this Youyang Gu person, right? Uh, but once my model was added to the CDC website, then I think like suddenly that gave kind of my model a lot more credibility, and like I suddenly
Mm.
had all these the same people, the same journalists that right like didn't like ignored my messages, right, a couple weeks ago, suddenly were like replying back to me, oh, like, hey, like do you have time to talk this week? I want to talk about your model and things like that. So yeah, that was an interesting experience because right, I've never kind of dealt with that before.
Yeah.
Um, so it was it was I don't know, not much I can say about it. And yeah, I think it was interesting, but I think at the end of the day, right, I really just like building models, and I get kind of joy from seeing kind of how accurate or right, like how
Yeah.
good these predictions are. And if the model's not accurate or my predictions aren't good, then right, like I want to work harder to improve on the model, right?
Mm.
So the I guess kind of the attention is maybe an added bonus, but I think I realized that I don't really care that much right, about
Yeah.
whether or not, right, like I get that.
Mm-hmm.
I care more about, right, like I want kind of the answers to
Yeah.
be right. I want people, not just me, right, just other people who are doing the modeling, right. I want them to make sure that right they're doing a good job making
Yeah.
sure that people understand what a model can and cannot do, and kind of outlining the assumptions and making that, being clear about that. So
Mm.
that's kind of the thing that I think I care more about, and of course it frustrates me that some like other institutions out there who right don't whose model may not be who isn't as good, and they don't they don't take criticism well. They just like right, if you tell them their model is wrong, they're like, it's too bad, right? Right, so right, like one of the institution that the White House was repeated silently, like people kept telling them your prediction is too low, the prediction is too low there, and they don't do anything about it. They actually,
Mm.
it wasn't until I think like May that they finally changed it one day from the day before was like 80,000 deaths, and then the next day like, oh, we updated our model now there's going to be 150,000 deaths by August. So it's like, right,
Yeah.
like how does a model just jump from 80,000 to 150,000? They're basically doubling, right,
Mm-hmm.
overnight. And and you ask them, what happened? They're like, oh yeah, we just like made some changes. We looked at the data. we use the latest data and update them. But like, you can't. These are people's lives we're talking about. Right? People,
Yeah.
the government, right? Like people, experts, right? Decision makers are using your model to make decisions about people's lives, right? And you're just out there like tweaking, like basically like turning a knob on your model and being like, oh yeah, like today, we turned it up. And I think that's just very irresponsible. It's an
Yeah.
irresponsible thing to do. And so, I wanted to use my platform to kind of speak out about that.
Hmm. Yeah. I think that's great that you, it seems like you're highly aware of how social media can impact you and how to use it to build better models instead of, getting into unnecessary arguments. So during the process when people have doubts on you and also you realized, you know, when CDC cites your model and other universities use your model, there's also a lot of responsibilities come with it. So have you had times that you also question your own model or had fears?
Yeah, I think like I mean, right, like I always think, yeah, like I mean, maybe right, is my model doing the right thing, right? Like, is it what it's, right, if it's doing what it's supposed to be doing, and yeah, I mean, it's also right, like when I go on say social media and people saying, oh, like this guy's wrong or whatever, it's
Yeah.
not easy. At the end of the day, I had to, I just like kind of rely on kind of my experience, right, with
Mm.
working with, right, data and making predictions, and just say, okay, like, right, like this is the best that I can do. I'm going to try my best to make it, right, as accurate as possible. But at the end of the day, right, like everyone, nobody is perfect 100% of the time. And so as long as I try my best, right, then I have to be okay with, right, whatever the results are going to be. And unfortunately, right, like not everyone understands, right, like modeling isn't about kind of like getting the right answer, because no
Yeah.
model, nobody can predict the future, right? that's
Yeah.
that's kind of right, like something lesson number one. And if, right, like in modeling is, right, it's not a crystal ball.
Hmm.
A model's prediction is, right, is about kind of your assumptions, and also it's not just a one single number, right? It's not like, oh, the model predicts there will be 3,154 deaths on this date, right? It's a spectrum, right? It's a
Yeah.
confidence interval. But of course, right, like the to a layperson, right, it's also like, for example, if you're a journalist writing a paper, or writing a story, you don't want to give a confidence interval, or like you want to say, oh, that this
Yeah.
model's 95th percent confidence interval is this death to this death, right? That people want to have, right, kind of like a concrete number, so they always say, oh,
Yeah.
this model predicts this many deaths. But of course, right, if you actually look at the model, it's more about a range rather than a
Mhm.
particular number. But then when people read, oh, this model predicts this number of deaths, right, and then and the actual number ends up being, off, then they're like, oh, this model is wrong. But then you see, oh, like kind of they're in the confidence, it's still in the confidence interval, right, of the
Yeah.
model. So right, the model isn't wrong. It's just, right, maybe the 50th percentile is wrong, but
Hmm.
right, that's not going to happen. You can't have you can't hit the 50th percentile every single time. Then if that does happen, you got to shrink your confidence interval, right? So,
Yeah.
but I mean, I guess in reference to, right, the other institutions that were kind of giving out bogus numbers, right, I was referencing their point estimates,
Hmm.
but also right, their confidence interval was also wrong. It was like something like, oh, they predicted like 60 to 75,000 deaths, right? Like their confidence interval
Hmm.
is super narrow. When you're predicting several months out, you really need to have a very wide confidence interval. If it's not
Yeah.
wide, then you're doing something wrong, because, right, nobody can be that accurate. Uh,
Yeah.
so that's just something that kind of I learned is, when in doubt, you have to widen your confidence. And I know people, right, like people's, I think it's a common kind of, not, I don't want to say mistake, but a tendency, right, for people to be overconfident about what's going to happen, right?
Mm.
Even if something is like 60% likely, right, there's people that are doing studies. They ask people what are the chances. It's always higher, right? It's always like, oh, like 80% or 90% when it's in fact 60%. So we have to understand these like biases. Right? These are like human biases that, right, like that are innate when we're at the end of the day, like it's humans that are building these models. So we
Yeah.
are going to introduce biases to the model, even if the
Right.
model itself, right, doesn't have any biases. But we, as humans, introduce biases, so we have to be aware of them and try to catch it before we, right, allow the model to reflect those biases.
Yeah, I think that's a great point because, like you mentioned, the decisions we make around what type of data you're going to use, the features you're going to select, and also how long, what's the duration of the data you want to put in, right? Like, what is your definition of the outlier? I think whenever we make a decision, we need to have the awareness of, okay, everything is a assumption you make. I think in our work, we document even those seemingly intuitive decisions is helpful for us to kind of just reflect on and later check, oh, was it some of these assumptions I made that impacted the model, whether it's a good decision or bad decision. So now looking back of your previous past decisions, what are something you would do differently if you were to build a whole project again?
So I guess that's like kind of two answers to it. Like on the one side is I feel like there's like so many different things I can like do differently in
Mm-hmm.
terms of like the model or right, like just how I influenced the right the approach or whatever.
Yeah.
But like these are all kind of going to be like pretty minor and probably not make really much of a difference. So, at the end of the day, right, like I think like I'm just like very grateful that, right, like for kind of everything that has happened, over the last, I guess now almost 2 years.
Mm-hmm.
And, there isn't really anything that I think like I could have like done differently that would have, changed the outcome of anything, right? I think that's something that I thought about a lot in terms of like, is there could we have done something to change, right, the outcome of, right, this whole pandemic? And I think this is also one of those cases where like people are tend to be overconfident about what they
Mm.
can do. And unfortunately, if you actually like look at, right, all the, right, like in throughout human history, we've had, all these pandemics. And I think it's erroneous for people to assume, oh, like, if we had just done this or that,
Yeah.
the pandemic will be over. That's I think that's very optimistic thinking.
Mm-hmm.
And, in terms of, right, obviously, if you're gonna use it for kind of political purposes, sure. I mean, like, I can't do anything about that, right? But
Mm-hmm.
in terms of like as scientists, right, that's people who look at the data, right? It's very difficult to see a scenario where things would be drastically different than where they
Mm-hmm.
are today, and which is it's an unfortunate thing, right? Like because if you look at the
Yeah.
U.S., like I think like a million people died from this pandemic. And maybe like for me, just say, I can't be saying that there's not much we could have done to save those million lives. I'm not necessarily saying that we could have done. There's nothing we could have done, but I'm
Mm-hmm.
saying like in terms of like if we want to be realistic about the things that we could have done, right, that would have a realistic shot of achieving success, right? Obviously, like
Mm-hmm.
things like, for example, oh, if we just shut down the country like China did, right, and
Mm-hmm.
for 2 years, right, because China, right, they're still in kind of have a much rigorous state of, right, enforcing these restrictions, or not restriction, but kind of, right, honing down COVID. Yeah, of course things will be different, but the US is not like China and China is not like the US, right? So it's just like very there's you can't compare the two. And so we have to be realistic about kind of the things we can and cannot do, and looking back at kind of what the things that I could have done better. Yeah, I mean, there's probably like 100 things I could have done better, but what does any of that really matter? Probably not. So I try not to kind of like think back, oh, I should have done that or should have done this,
Yeah.
and just kind of look forward, right? Just like learning from everything that I've done in the past. What should I do next? That is kind of right that has the most potential impact to positively influence others, for example.
Yeah, that makes sense. Thanks for sharing that. And your model outperformed a lot of models produced by medical experts. So, do you feel your lack of experience in medical and healthcare actually become a advantage?
In some ways, yes, because I don't, like I said earlier, there's people have a lot of biases, whether they realize it or not. And I think with the situation with COVID, I mean, of course, it helps to have knowledge about infectious diseases in general. Uh, but like COVID is the name of it is right, and it's a novel coronavirus, so there's a lot of things we simply don't know about it. And so for me, like I come in with a blank slate and say, okay, I don't know anything about COVID. I'm just going to let the data tell me right what's going to happen, and just kind of completely rely on kind of right what the numbers are saying. Well,
Hmm.
not completely, but right for the most part, right?
Yeah,
Kind of
yeah.
relying on the data. And so then that helps kind of take away a lot of these biases, or even right, like or these assumptions that could be wrong.
Mm,
And so I think a lot of people in the academic or medical community, right? Sometimes they like, not saying it's a bad thing. I have these issues too, right? Where like we hold on to these preconceived notions or biases, even like when the evidence says otherwise, right? Like for us, it's like, oh, like we believed it was true for so long that right, like this
mm,
data must be wrong, right?
mm,
Rather than us being wrong. And so when that type of situation happens, it's unfortunate. But luckily for me, right, I didn't have to deal with that because I don't have these preconceived biases, at least for this
mhm.
field. And so when the data says, oh, like, right, if the data is saying one thing, then I think, okay, like, doesn't make the most sense, but if it's saying this and then I test it out of sample and it's awesome and it's still saying the same thing, then like I have to believe in it.
Thanks for sharing that. So basically, yeah, you have your procedure, right? Through your testing, validation, it is right, even without a lot of backing from the industry. You have confidence in the model. So I think uh, this is a great lesson for other data scientists to learn. And sometimes we stay in the industry so long, it's hard for us to differentiate what is truth, what are the assumptions. So do you have any advice for someone who has already kind of become an expert? How can they, it's also exhausting to say, oh, I challenge my belief every day. What is like some actions we can take to remove this bias? Is it to just introduce new people in the team, or what are your thoughts on this?
Yeah, I think there's a couple things that you can do. One is just to kind of be open to different ideas. Right, that's the number one
Mhm.
thing. I think with our current political climate, right, we tend to kind of shrivel up and stay in our own little community where like everyone have the same opinions and thoughts about something, and then
Yeah.
you never kind of venture out because you think, oh, like the other side is just right, is just wrong. And that's dangerous because right, maybe like you're right, your group right is right, the majority of the time, right? Maybe even say 80% of the time, but there's still 20% of the time you're wrong. And
Hmm.
so if you always right stay in this little bubble, then you always be wrong 20% of the time. And so I try to right kind of be read from a variety of different sources, right, from all different perspectives.
Yeah.
And so I don't necessarily agree with everything that I read, but that's okay, right? Because I now understand that perspective, and so it helps me right think about right different from different sides, right, how people think. And so I think that's kind of a number one thing we can do. And then in terms of like more concrete examples, right, or in modeling, right, I think too many there's an idea I've seen too many people make kind of the mistake where right like you basically basically too many people just overfit on their data. And I've worked in finance, right? So I know, like, not basically when I was working in trading, 99% of the ideas I tried did not work. Right? It's actually crazy, right? I
Yeah.
like I in when I'm training the model, even you would have training, validation, testing, right? And so I would come up with some idea. I would do some back test, and then like on in right like in the back test, this makes a lot of money. So I'm like, okay, this is great. Right? Like, let me, I'm right, like I'm gonna be rich, right? And then you deploy this change in like live trading, and you realize it doesn't do anything, right?
Yeah.
And if any worse, it loses money, right? So, but but when I'm doing the training, even on the test set, it makes money, right? But so I think that's a common mistake people make is right, like they have their data and then they break it into right training, validation, testing. They do like cross validation, right? You
Yeah.
go through the whole procedure, and at the end of the day, you say, oh, like this model is great on the test set, but that test set is technically still the training set.
Right. So
Because
in the same distribution.
right,
Yeah.
the only true test set, the only true out of sample data is the future,
Yeah.
right? So what's going to happen in the future? So you can try to make your model as great as possible using the training data that you have, but the only way to test if you're right or not is right to deploy it and see what happens in the future. And so I think people, when people have a lot of us opinions about right like what's going to happen, uh in or like if they have an opinion about my model, right, I'm just like, okay, like why don't you tell me what's going to happen next, and let's see who's right, right? Because we can
Yeah.
talk about right, like all the like this model should have done this model should have done that, but at the end of the day, right, the model's purpose is to predict the future. So if you think you do a better job, then why don't you make a prediction right today, not tomorrow, and then see what right tomorrow what it actually is. And so if then we'll see like who's really right and who's right maybe not right. So uh that's kind of my advice is right like anytime you're unsure about something, right, just make a prediction and see if you're right or not, right? That's the best way to test is right testing it on data that you never ever seen before and no one could have seen before.
Yeah, that's a great point. And based on your experience in finance, in trading, what are some other lessons you learned from there that you kind of adopt the mindset when you do this COVID project?
Yeah, I guess I mean we talked a little about it throughout this session, but right, just being skeptical of just all data, right? If
Yeah.
don't throw in right features that you think could work if they don't really make sense. So for example, I think like a lot of these academic models, right, like we're using things like humidity or like elevation
Yeah.
or right like air. There's one I saw was like air traffic into airports, and just like that is those are so they're not useful data, but because they like one of them is like because they had something like pre-existing connection with like they're able to get the data source, and it's like proprietary. They just okay, let's throw this in to make to the COVID model, see right, and publish a paper about it. And
Yeah.
but like in reality, it doesn't do anything,
Yeah.
and actually probably makes the model worse. So those are just kind of the things to be mindful of when we're making these models. That like not everything, actually most things are useless. Right? Like so, what I said, like 99% of things are not useful. So you should just focus on try to figure out what that 1% is, right? And then once you figured it out, then spend all your time, right, trying to optimize on that 1%.
Yeah. I think that's a great advice. And especially as a data scientist, I know when I have some data sets available, I get very excited. I want to play with it. I think it's okay if you just, play with it, try it out. But if you actually want to solve the problem, the available data set doesn't mean those are the best data set. Maybe I think some exercise we do is to imagine if you can have all the data you have, regardless of whether they're available or not, to see what are some data that might actually be useful. If maybe the data available are useless, and then we actually need to build a pipeline to collect some new data. And I think it's important to not to be limited by the availability of the data you have, and then instead of have a fresh eye to look at the data to evaluate how relevant they are to the model to solve the problem.
Yeah, no, you're
Um,
exactly right. Yeah.
Yeah. And I think in the beginning, you're focusing on looking at the data, looking at data quality, and then build a model. Later on, you probably spend more time to look at the news and learn the domain knowledge. Do you have a I don't know if this is a question that like, do you have a kind of a breakdown of the time, how much time you spend in the beginning in learning the domain knowledge versus like later on in a project? Do you feel you have to learn more domain knowledge when it comes to like making small tweaks on the model?
I think it's a gradual process. I would say like in the
Mm,
beginning, right, I had to learn a lot very quickly. So I guess there's like kind of a very steep learning curve there.
yeah.
Well, not steep learning curve, but just like a steep amount of time, like where I'm just
Hmm.
like learning. And then after right, I've released the initial versions. It was more focused on like optimizing the model rather than kind of like right, like learning more on the domain knowledge side. But then right, like after that has gone, right, then I encounter kind of the next phase where right, like
Hmm.
things like the pandemic is changing, right? The pandemic, how the pandemic operates in March 2020 is very different than
Yeah.
how the pandemic operates in August, July
Mm,
2020. And also by July, August, there's a lot more papers on COVID than there were in March. Right. So then kind of the next step, I had to kind of relearn or like re-update, right, kind of what I know about the
mm,
disease to continue to be able to right maintain keep an accurate model. Then I had to kind of like go back and learn a lot more about like these things, like what is the actual kind of infection fatality rate, right? Why do
yeah.
some countries, like for example Italy, have a much higher infection fatality rate than right a place right, like, say uh, like Utah, right? And it
Mm,
turns out that right, age is kind of one of the age is the biggest predictor of COVID mortality. There's I've been kind of doing more research in that aspect, and kind of like what are the best predictors of for an individual person, right? Their chances of mortality from COVID, and the number one thing by far is age, right?
mm,
So the older you are, the more susceptible, and it's like an exponential function. And so that's something that right, like once we learn that, it's like right, like it's very important, right? Because that means that right, there's all these things you can do to right reduce your risk of right, like of COVID mortality, but right, like you can't really get younger. So right, there's only kind of a limited the kind of amount of things you can do with respect to that. And so that does have repercussions when it comes to like policy, for example, right? And all these different actions that you can take. So it does help to kind of keep being updated on kind of the latest research.
Mm-hmm. Yeah, I would love to talk more about your current research on that topic. I think on Twitter you also mentioned inequality is one of the factors as well. So recently I read you have a blog on what it means to be an expert, and you talk about groupthink, crowdsourcing. Can you share a little bit about what made you want to write that blog post?
Uh, yeah, because I mean, I think about it a lot too, right? Like, oh, like
Mhm.
why, right? Like, why was I someone that, right, like a lot of people reached out to, or right, like looked, or like my website was something that like people looked at as like a source of COVID information when, right,
Mhm.
a year or two ago, I had no idea, right, what what the word epidemiology even meant, right? So it was kind of interesting to kind of be a part of that, right, process from right being a nobody to right someone who like created a model that a lot of people cited, a lot of
Mhm.
prominent kind of right like organizations or sources went to for COVID information. And so I think right that I realize it ties a lot with right like how our society has advanced right to like kind of we're in this new information age right where anybody can have access to such a wide breadth of information from the comforts of their own couch, right, their
Yeah.
own desk, their own home, and you can go as deep as you want, right? It's not like oh, like there's only so much you can go, right? Like right, like, think about just like how much information you can find out from just right like a few hours of reading like the web. And so
Mhm.
I think this idea where right like this idea that oh just you don't have a PhD in virology or right, like public health or epidemiology, right? Like this credentialism way of thinking is a little bit outdated because right, like we're coming into an era where right, like people aren't just a one trick pony anymore. Right? We understand a lot more about the world than people right, like our parents' generation or our grandparents' generation. And
Mhm.
so that's something that right, like the world has to adapt to, right? Because there are a lot of people that know a lot of things, but they're not necessarily devoted to that one thing. Uh, so that yeah. So I mean, I just like think about that. It is very kind of quite interesting to see how the world has kind of progressed in that direction. So I'm actually like kind of very hopeful for the future because it means that right, the next generation of people, right, like, I guess like the Gen Zs and right their kids, right, they're going to be able to you know understand even more than I do, than we do, and
Yeah.
so hopefully that means that they'll be able to do more too, right? Accomplish more
Mhm.
things with right what they're given. So I'm hopeful.
Yeah. Thanks for sharing that. And I really enjoy reading the blog. It also made me think because you mentioned crowd sourcing is very effective. And I was thinking like groupthink. There's also opinions from a lot of people why crowdsourcing can work better than groupthink. And then I realized, well, groupthink. I think the assumption is the group of people, although there are a lot of people, they're from the same background. You can think of you're sampling from the same distribution. But crowdsourcing, I think crowdsourcing might not work if we are crowdsourcing from also the same group of people. But it will work better if you get opinions from people with different background and make sure the opinions are diverse. So think about like ensemble models or like random forest. Each tree is built
Mhm.
independently. So that's why the ensemble works. And also, I think you mentioned some recent COVID model. I think maybe last time we chatted was actually like an ensemble of a few different models. So what do you think about? So yeah, that's kind of my idea of crowd sourcing versus groupthink. You need to really make sure the source of the opinions are diverse. So what do you think about kind of the difference between crowdsourcing versus a groupthink?
Yeah, I think you're right. Like there's right that you have these kind of two sides, and of course, my belief is right like you have there has to be some kind of balance in the middle, right?
Mm.
Where you don't want to go off to the extremes, right? Where you rely on say a group of people who right, are very who have right the same kind of distribution, the same kind of knowledge base where they're
Mm.
basing their opinions on at the same time, and you don't want to just like go out and right ask for random people's opinions and be like this guy's opinion is equal to right some this other person's opinion who it may be like who may have studied right this topic for
Mm.
their entire career, right? So there has to be a balance where like okay like we want to put more, so it's kind of like right putting priors, right? There are these individuals, right? You have higher prior, you give them kind of higher priors, higher weights in the beginning because because of like their backgrounds. But
Yeah.
if you're sampling new data points and you see that they don't necessarily agree with each other, then you got to lower their weights, right? Lower their priors. And so then you kind of try to shift your focus to those that were able to get right these data points right. Right. So you kind of like give them more emphasis. I think that is a machine that is a machine learning technique. I don't remember the name of it. But
Mm.
right, it's kind of like that idea that right you favor those that are right more, and so
Hmm.
you kind of update right I mean I guess that's like a Bayesian technique, right? So
Yeah.
you kind of just update your priors, and then you kind of like or update your posteriors,
Hmm.
and you iterate through that process. But yeah,
Yeah.
my opinion is just right. Like there is a balance, and we have to figure out a way to strike that balance. But unfortunately, in this right climate, it's like very difficult because right, you have, for example, these social media giants whose task is to push you to the extremes, right?
Mm.
The people who are kind of in the middle, they don't get as much of a voice because right, no one really cares if you're like, oh, I could go either way. But right, the moment you
Yeah.
go say, oh, I am strongly in favor of this, then that's when you get a lot more engagement. Of course, that's good for these companies, but not good for society.
Mm. Yeah. Thanks for sharing that. Previously, you mentioned that you read Signal and the Noise and 538, the blog by Nate Silver. Are there some of other books or people's blog you read that had a influence on your work or on your career in general?
Yeah, I think uh, right that we talked about the little bit about like right the crowdsourcing, right? Like so there is
Mm.
this books like super forecasters that talks about like these ideas of you know these people called super forecasters who are kind of doing better than a lot of these traditional experts. So I think it's a book uh, from kind of a few years ago that they talk about this very phenomenon, and so that's something that I read that I think right that helped me understand kind of this landscape. But in general, other stories and things I read, I think I don't have one kind of particular, but right, usually just kind of being able to uh, be open to a lot of different sources, right? So even
Mm.
right, like sources we traditionally will like not pay attention to, but like even if they're right, say 10% of the time, that means if you read 10 articles, one of them right is correct, right?
Yeah.
So I think just like kind of the volume that for me just like reading and trying to understand is very important. And I guess like one uh, blog that I really like is Tyler Cohen's Marginal Revolution.
Mm.
I think there's a lot of good ideas on that blog that I mean I'm not normally exposed to. So I think like I really enjoy reading it because right, like I don't agree with a lot of the things necessarily
Mm.
that right are there, but it's very interesting to read, right? Because I get to see another perspective. And sometimes I read it and I'm like, oh, okay, so that's why right things are work that way because I never understood it before. And so right, it helps me kind of shape my opinions as well. Because right, if I'm just reading things that right I agree with, then that I don't learn anything from it, right?
Yeah,
Because I already
yeah.
know all these things. So I have to right, we have to challenge ourselves and go right, go learn about things that right like
Mm.
we don't necessarily like or right, or we don't agree with or things are just different. So
Yeah. I think that's a great point, and it's uncomfortable. Sometimes I know I don't agree with his opinion, but I also don't quite know the other side. I know I should probably read about it, but it just have this mental, I don't know, fear. I guess you don't want to realize that, oh, maybe I'm wrong, so you kind of shut it down.
right,
Yeah, I think it's also important to recognize this type of bias or ego we have, and then also, like you mentioned, just have that curiosity to understand the perspective from the other side. Do you have any mentors you so during the COVID project or in general that you talk about your project to bounce off ideas or some peers?
not much. I think we just talked about like I just use Twitter as kind of my main source, I guess.
Mhm.
I mean that was like kind of the best I could do, right? Given the fact that like we all had to kind of stay home for 2 months.
Yeah,
Um,
yeah. And what are something you're working on right now?
yeah, so as you mentioned, kind of I'm currently one of the projects I'm working on is I'm on the WHO United Nations Task Force, right, to look at COVID mortality and more specifically inequalities in between and within countries and how that can influence mortality in the region. And so,
Mhm.
that this is like one of the, as we kind of go through the next phase of the pandemic, right? Like looking at how inequality shapes neighborhoods and, right, and cities and regions in terms of, right, the impact of COVID is kind of, it should be, I think more people should be looking at, right?
Mhm.
Because if we look at the high level, right? If you just look at, the high level data, oh, this country has this many deaths or this state has this many deaths, it doesn't tell us the true distributions where like where these deaths are coming from, or like even more generally, like which regions are more impacted than others, right? And it
Mhm.
turns out that right, like wealthier communities, wealthier regions are much better positioned to right withstand the pandemic than right more vulnerable or poor disadvantaged neighborhoods. They just get disproportionately affected. And so it's like how in kind of what degree does this impact kind of characterize this impact so that right we can work towards right reducing these disparities that exist in our society so that the next time a pandemic comes right then we can be better prepared for it right because right for example right like access to healthcare right those in kind of vulnerable, disadvantaged communities simply don't have access to good quality healthcare to begin with, right? Not
Yeah.
even just like not even before the pandemic existed, there wasn't kind of a structure of good, right? Having that solid healthcare system to take care of a community. So people aren't in good health to begin with. And so, of course, when the pandemic comes, right, that will disproportionately affect those individuals. And of course, on top of that, right, there still isn't a good healthcare system during the pandemic in a lot of these right vulnerable communities. So that's only going to exacerbate the issue. So my kind of the goal of our task force is, of course, to look to do an in-depth analysis, right, and try to right, point out where in the world, right, where the data gaps are, and kind of highlight, bring to attention to right a lot of these UN member countries, right? What are things that they can do better to right one address the data gaps, and then two, right, once the data gaps are addressed, right, what are actionable items and policies that can be placed such that right, we can kind of reduce these inequalities and kind of in effect reduce mortality for right, the next pandemic.
Yeah, thanks for sharing that. And whether I'm thinking about the COVID project you built or this current project, those are not using like very complicated, say, deep learning neural network model. And the main challenge is actually understanding the data. And another thing is asking the right question, right, to see what type of answer that might make impact on the society. I think that's kind of different from a lot of data science, how they imagine data science work. So what is your current day-to-day like when you work on this task force?
Yeah, so we meet kind of like probably like every other week or so. And so I usually just try to either right if I'm not doing kind of background research, just like going through like the database of right like articles, trying to figure out which ones are relevant. I would try to just kind of do some more modeling on the side. And so I think in general, I'm also kind of working on some other projects, and they're all kind of related with each other in the sense that I think right, COVID has really exposed right the fact that right like we as a society don't operate things a lot of things based on data, right? We
Yeah.
operate more on people's feelings or beliefs and whatnot, and it's very
Yeah.
not as much data focused as I would like. So I think I'm just trying to I'm working on a project to like kind of like build something that maybe like could try to bridge the gap right between kind of a lay person trying to understand data and seeing how all of these things that I've tried to kind of built in the past 2 years, if there's a way to basically like automate kind of that process, right? The way that I think is like whatever problem that I tackle. I think a lot of the things I go through the same checklist of things that right like I think about when I receive a new data set. I'm sure you do as well. And so trying to maybe put kind of that idea, those processes together, and seeing right like being able to use that more generally, more broadly, and not so that right, it doesn't have to be me right here building a new model every time, but maybe right like if
Yeah.
there's a way to kind of right streamline that process, and of course that has potential to also kind of impact the work that I'm doing with COVID as well.
Yeah, that's super interesting. So, are you writing, sharing your checklist or your process when it comes to modeling?
Yeah, I mean, I talked a lot about it already. In throughout our conversation today. Uh, but I think yeah, so I think like I'm still kind of in the process of trying to figure out exactly right which parts can be generalized right to solve any problem, which ones are more right like needs to be especially tailored to each individual problem. And I think of course
Yeah.
that's always the golden key here, right? Because if you can figure out which one is which and which one's important, then you can right, basically solve any arbitrary problem much more easily than right having to basically start from scratch every time.
Yeah. So do you have any, I know there might be a full list, but do you have any specific example on what can be generalized and what need to be tailored?
I think, I guess, modeling, with respect to modeling, I think we had this tendency, or a lot of data scientists, like, always had this tendency to just sort of like try, highly complex models as their like first thing. Um, right. Oh, like, right, just gonna, if someone's given a data set, oh, the first thing to do is just like, right, like run it through a neural network. And of course, that's not the right way to go. But unfortunately, I think a lot of people who don't understand data want, right, like they actually want people to just run or know a network on it, because then it sounds right cool. It's something that they can like present to, right, the higher ups, and they're all like, right, like we built a neural network model or whatever.
Yeah.
Uh, but of course, right, like my kind of approach is you always have to start with linear models,
Mm.
and only when you realize, right, when linear models aren't sufficient, that, right, you should try to do higher order, right, or non-linear models. And I think
Yeah.
actually, in my experience, right, like 9 times out of 10, a linear model is sufficient to do whatever task that you want. And of course,
Yeah.
in sample, the R squared, or the mean squared error may not be as good as a neural network, but I promise, right, people that out of sample it will do better. But of course, right, like not everyone believes, right, not everyone knows that, and right, because they only see, oh, like test R squared, right, and of course their test data is still training data, but
Yeah.
they see the test R squared, they're like, okay, this is better, so then they use it, and they never kind of go back and check with like the real out of sample data to see
Mhm.
if, right, the model is actually better. So I think that's kind of probably the single most important thing, is just like
Mhm.
the choice of model. You want to start simple, keep it simple. Just, right, like how when I modeled right, built the COVID model, I want to keep things as simple as possible, right? Just
Yeah.
just start with one feature, right? So that's kind of the fundamental, right? Just basically focusing on the fundamentals is, I think, the most important advice that I can give.
Yeah, that's a great advice. And what are something that needs to be tailored?
I think what needs to be tailored is the choice of, I would say, probably like choice of features to some aspect. There are ways, right, that you can do like automatic feature selection, for example. Um, but you can throw, for example, I've been working on a project where I took basically like 6,000 indicator, like 3,000 indicators. I think
Mm.
like 1,000 from like the World Bank about like different countries, and maybe like a few other thousand from like our world is data. They have like a data set, and try to like use those 3,000 features to see, right, like which ones can be used to like predict COVID all cause mortality for each country. And so if you, right, just throw all of those features in the model with only 200 data points, then I think I got some like like weird result where it's like the most like kind of the most predictive feature is something like soybean exports, right? And of course, that doesn't make sense.
Yeah.
And because, right, if you come up with enough features, you will find some some feature that can, right, predict your Y,
Mhm.
and of course, so having to be able to like figure out, which features we want to like keep and which ones we want to throw out, is somewhat a manual process. But like, I'm not saying you have to like handpick every single feature. I'm just saying, right, like you
Mhm.
have to look at, right, what the model is outputting and be able to tell if this makes sense or not. If it doesn't make sense, then make the appropriate changes, so that, right, it can make sense. So, right, so for example, I would then have to like remove like, so like say features that are like say agriculture based, or maybe they don't have enough data points, or maybe only 50 countries are providing soybean output export data. right? So maybe I only restrict my feature set to those that have data points for 80% of countries, and then it's much harder to find some spurious correlation if you have n equals 150 rather than n equals 50.
Yeah. Thanks for sharing that. What are some other advice that you see you want to give data scientists?
uh just try a lot of data sets as possible. Right, work with different data. I think, right, if you spend all your time just like trying to like optimize one data set, then right you may not be able to realize what things are generalizable and what things are
Mhm.
not. So being able to like work with different data sets on different industries and all of that is helpful. Right? So for me, right, because I worked in tech, I worked in finance, right, I
Yeah.
worked in sports, sports analytics, and then now with COVID and health, right, public health.
Mhm.
Then that gives me exposure to all these different industries and how they, right, like work with data, and so I kind of can then better see what processes are generalizable and which ones are not. That's helpful to know when
Mhm.
building the next model.
Right. Don't put yourself in a bubble. And before we wrap up, how do you see your career in the future? Do you think you want to continue work on public health, or what are some other ambitions in life you have?
I mean, to be honest, right, I don't really know right now.
Mhm.
Right, like I think
Yeah.
this is one of the things that I've been kind of like trying to figure out, because
Mm.
during COVID, I was spending my whole time working on the model, and then of course now that COVID is kind of winding down, right, I'm kind of going back to the question where like what should I do next, and
Yeah.
I no longer, like part of me no longer feels like but just wants to go back to what I did before, because right, like I see kind of this last 2 years, I've been exposed a lot more to, right, all these kind of problems in our society. I don't know if that's the best
Yeah.
way to put it, right? But like, right, when I was in my early 20s, I was just focused on doing good, right, doing good at my job and learning as much as I can, right? Maybe, right, like make some money. But like now, it's like what's like we see a lot of people that, right, like that. There's a lot of inequalities. I'm in the task group that looks at inequalities, right? And I feel like I have the skill sets to maybe, right, like try to be able to kind of work on you know being able, right, like help publicize a lot of these issues, right, and
Mhm.
maybe like work on potential solutions to address a lot of these inequalities and disparities in society. I'm still not quite sure how I can best do that, right?
Mhm.
So I'm just trying, right now, I'm trying as many different projects as possible to see
Yeah.
what is interesting to me and what I can kind of, right, have the most impact. So
Yeah.
to answer your question, I'm not really sure, but I know that I want to be able to, right, like work on something that can make a positive impact or has a positive influence on, right, just like uh making the world, right, better than where I found it. So
Yeah, yeah, that's great. And what are some other project you're trying right now?
well, I guess, right, I think the one I've been thinking about and been trying to like put together a demo or kind of an MVP of sorts, right? Is like seeing like if there's a way to generalize kind of my process of how to approach a problem when given, right, some data
Mhm.
set.
Yeah.
So kind of like you guys, so you probably aware like the whole like auto ML scope of things, but I think
Mhm.
current the current kind of ways we're doing auto ML, like, and a lot of the current solutions out there aren't sufficient, because they don't
Yeah.
really tell people like what is the problem with the data. They just say, okay, you give us the data and we'll build a model for you, right? But
Yeah.
for all we know, right, you get it's garbage in, garbage out, right? So uh, but of course, these companies they're not going to tell you that your input data is garbage because they want your business, right? So I'm just trying to think, trying to see if there's a way, right, we can try to like understand the data a bit more and understand the input data a bit more and seeing like, oh, if there's ways to we can you know, to better um, how good of a model we can build with the input data and what are the potential issues with it, right? Just kind of being more realistic with what right, the data sets can and cannot do, rather than just throwing it into some neural network and then spitting out
Yeah.
some answer. Because actually, that's what a lot of these companies these days they're doing, and they literally just like throw in a bunch of data and then into some right open source model, get out an answer, and then say, okay, like here's your answer, right? And then right they're able to raise millions of dollars in funding, but does it actually solve any problems? I'm not sure.
Right. Like, does the model also look at the data from the information level, from the feature level, right? And also, like, how do you validate that when we don't have the real data out of the sample? I think that's also like something interesting to think about. And I have another question I always want to ask you. I'm just curious because even on Twitter, social media, you talk about data science. So, what are you doing when you're not doing data science? Who are you as a person?
Oh, uh, first, I'm also trying to figure that out myself. Um, but I mean, for right, there are some people that like, oh, like right, like you take right, like you do something because it's like your job, right? And
Mm,
then for me, I mean I genuinely just like enjoy looking at data, you know, building models based on the data, trying to right, like see if I can predict something.
mhm.
So for me, I'm lucky in the sense where like my job is also like one of my hobbies.
Yeah.
But of course, I can't just look at data all day. I do need right like other aspects of I do need to find other hobbies as well. So that's something that right after the COVID began winding down, I've been trying to figure out kind of other things to do. So I'm actually currently out here in Salt Lake City, uh, and trying to visit kind of the ski slopes here.
Oh,
So
nice.
I do skiing, and I also recently took up snowboarding because I thought like I already I've been skiing for uh, like 10 years now. Let me try snowboarding.
Mhm.
So that's been kind of my weekly. Every weekend I just get up at 7 a.m. and
Oh,
then just
wow.
drive to the slopes, try to beat the crowd. So that's been
Yeah.
kind of an interesting experience, and
Oh,
I
that's
want to try to
awesome.
get better at that.
Yeah. Are you gonna try some freestyle skiing?
Uh, oh yeah, yeah. I've been watching the Winter Olympics. So
Yeah.
yeah, but like, oh yeah, like that looks really cool. I want to be able to do that, but I also don't want to break my knees. So yeah, unfortunately, I'm getting older, so I feel like I can't do as many things as I used to be before. But yeah, I think you mentioned the Olympics. I also, been trying to take up some hockey. So I think that's a sport. I guess like my friends don't really play, but I actually really like
Mhm.
playing hockey. So
Yeah.
so try to go out to the Salt Lake City has like some of the best kind of infrastructure for winter sports
Mhm.
because right the Olympics was here 20 years ago,
Yeah.
and so they actually have a lot of good facilities where you could go like skating or play
Mhm.
hockey and things like that. So I was trying to just like take advantage of all that, during the winter.
Yeah. That's awesome. I'm jealous. I tried snowboarding a couple times. I probably spend more time trying to stand up, recover, and then actually enjoying it. And also, I feel like when you play hockey, you snowboard, you meet different people. Some people have completely different background than you are, especially when you're in Salt Lake City. It's another way to break the bubble because sometimes I feel like I'm in Silicon Valley. I like everybody because everybody think just like me.
Oh yeah.
Um, yeah. So besides that, what are something exciting this year in your career or in your life?
Well, so I recently moved from New York to uh, the Bay Area.
Hmm.
So I've never really lived in the Bay before.
Hmm.
Was like I guess actually not too bad. I mean I went to high school right in Palo Alto, but since college I've never really lived in the Bay or since high school. And so I wanted to kind of just like give that a try, right? Because I work in tech, but I've never lived in
Yeah.
basically the tech mecca of the world. And so, New York was I've lived there for 3 years. It was really fun,
Mhm.
but I'm excited to right like move to California and try like kind of start to see what right the lifestyle on the West Coast and compare it to what right the lifestyle right on the East Coast. So
Mhm.
that's something I'm kind of really looking forward to is right just being able to I guess enjoy like the nicer weather on the West
Yeah.
Coast. That I will definitely uh, not miss the bad weather in on the East Coast. So
Yeah. That is exciting. So for folks who want to continue to follow you, follow your work, where can they find you online?
uh
You don't want to be found.
I mean, if I guess if there's things I would post it somewhere online. I'm sure people would find it. On like my website or Twitter. But yeah, I think like after right, a year or two where like everything uh, where I'm saying was like basically like like interacting with like random strangers on the internet. I thought I would take kind of like this year off a little bit and just
Yeah.
focus on like my own work and without kind of having to worry about what other people think. And then when
Mhm.
I'm ready to release it or announce it, I'll do that. So
Yeah. Um, yeah, I totally understand. I think you have a blog. Occasionally, you publish some blog posts. I can link it in the show notes if the audience
yeah,
want to
yeah.
read your
Yeah, I
articles.
want to, another thing on my list of things to do is I want to be able to write more.
Mhm.
I think people have told me like, oh, like the things you say are very interesting. And I
Yeah.
mean, I personally didn't really, I don't think I'm that interesting, but I guess some people do. So maybe I should try to like put down some of my thoughts. So, for example, about a lot of the things that we've talked about today, right, in writing, so that other people can see it. So yeah, maybe stay tuned. It will be on my website if I write something. So
Yeah. I really enjoyed the conversation. I learned a lot from you about your work, about your thinking, and I'm really looking forward to read more articles from you and learn more about your future projects.
oh yeah, yeah. Thanks, Aliana. It was great to be here with you today. I think it was a longer conversation than I guess I initially expected. But I guess for any viewers or listeners, if you get to this point, then you know, good job. But yeah, I guess yeah, take care, and I'm sure we'll stay in touch. It's a small world out here.